Hello all, I'm Sharon Blessy, a third year BTech student from Tiruchirappalli. I have completed the IoT internship in Emertxe. In this video, I would like to brief you all about what I've learned and have done in this project. I would like to thank my mentor Jayalakshmi ma'am for her constant guidance and to all who supported me throughout this internship. In the internship, we were first given an introduction to C and C++ programming languages. Next, we were given introduction to IoT and embedded systems. Then, we were guided to build an IoT-based home automation system as our project. My learnings. The internship was divided into two parts. The first part being programming. Day 1, we were given an introduction to programming languages, high level, middle level, and low level languages. Then we were given an introduction to C and about the applications of C, like system and embedded software development, OS kernel development, etc. Then we were taught about the important characteristics of C, that it is a general purpose language, free formatted language, it is efficient and portable, etc. Then we learned about keywords, which are reserved words. Then about the typical code structure, which includes documentation, that is comments, which can be multi-line and single-line comments. Then preprocessor statements, global declaration, main block statements, which include local declarations, program statements, and function calls. And then the function blocks. Then we learned about number systems and their interconversions, that is conversions between decimal to octal, decimal to binary, decimal to hexadecimal, etc. Then about the data types, which can be primary, which include integer, float, character, double. Then derived, which include array, pointer, structure, union. And then user defined data types, which are enum, struct, union, typedef, etc. And then we learnt about modifiers, which can be size based and sign based. Size, short, long, then sign, signed, unsigned. Day 2, we learnt about sign modifiers in more detail, signed and unsigned variables. Then we learnt about the conditional constructs, which can be single iteration and multi-iteration. For single iteration, if and its family, switch case. Then multi-iteration, for, while, do while loops. Then we learned about format specifiers, percentile D for integers, percentile C for characters, percentile F for float, and percentile LF for double. Then we learned about the printf and scanf statements. Printf is used to print and scanf is used to read the data. Day 3, we learnt about jumping statements, which include break, continue, go to, return. Then we learnt about the operators, which can be arithmetic, logical, relational, assignment, ternary, bitwise. And then we learnt about the overflow and underflow concepts, which are included in the operators. Then we learnt about arrays, about how we can declare arrays and its types. Then in day 4, we learnt about functions, what is functions, its advantages. Then we learnt about the parts of the function, which include the function definition, the function call, and function declaration. Then we learnt about how to pass values to the functions, which can be divided into two types again: pass by value, wherein the values are passed, and pass by reference, where the address of the variable is passed. And then we learnt about pointers, about its uses, and the referencing and dereferencing concepts using pointers. Day 5, we learnt about endianness, little endian and big endian. Then we learnt about pass by reference in detail using pointers, and then passing arrays to functions, and about returning arrays. Day 6, we learnt about pointer types, which include while pointer and null pointer. Then we learnt about strings, what are strings, and then we learnt about the string library functions: strlen, which gives the length of the string, strcopy, which copies the string, strcompare, which compares the string, and many more. Then we learnt about memory segments, wherein the random access memory RAM can be divided into user space and kernel space. The user space is further divided into stack, heap, data segments, code or text segments. Day 7, we learnt about storage classes, which can be divided into local storage classes and global storage classes. Local storage classes, auto, register, static, and global, again static and external. Then we learnt about preprocessor directives, which include, hash define, hash if and def, hash if def, and then about macro definitions. Day 8, we were given an introduction to C++ and then about the difference between procedure-oriented programming and object-oriented programming, and then about C versus C++ programming languages. Then we learned about class and object concepts, and then how to create a class and how to create an object. And then we learned about access specifiers, which include private, public, and protected. Then we learned about the constructor function, which is used to initialize object. It is a special member function which is automatically called when an object is created. Day 9, we learned about the destructor function, which is again another special member function which is automatically called when an object is destroyed. Then we learned about the principles or pillars of object-oriented programming, which include encapsulation, abstraction, inheritance, and polymorphism. Now for the second part of the internship. On day 1, we discussed about the project requirements, our aim of the project, the required software, the required components, and the methodology to be followed. Day 2, we learned about an introduction to IoT, that is what is IoT, its components, the systems, the cloud, the backend services that we are using in IoT and applications. Then day 3, we were given an introduction to embedded systems. What is embedded systems? Its types like real-time, standalone, mobile, networked, and etc. And then we learned about microcontrollers versus microprocessors and its applications. Day 4, we learned how to code to make an LED blink and simulated it on PiximLab. Day 5, we learned how to code to initialize and print text values on the CLCD and simulated it on PiximLab. Day 6, we learned to code and simulate how to read the temperature using the temperature sensor LM35 and display it on the CLCD. Day 7, we learned how to code to make the garden light for the project using the LED and the LDR. Day 8 and 9, we learned how to code to make to fill and empty the cereal tank, and we simulated it on PiximLab. On day 10, we learned how to integrate the Blink app by creating templates, adding data streams and devices. From day 11 to 14, we implemented the entire home-based automation IoT project. The goal of our project, to make an IoT-based home automation system which would be able to control garden lights based on sunlight, temperature of the home, and the inflow and outflow of the water tank. Then about the project tools, we use Arduino IDE to run the codes, PiximLab to simulate the Arduino Uno, LDR, LM35 temperature sensor, CLCD and serial remote tank, and Blink IoT app to create the button, link to virtual pins and gauges to measure temperature, volume and control the heater, cooler, inlet and outlet valves. The methodology. The IoT-based home automation project was developed and simulated using PiximLab and the Blink IoT mobile application. The methodology involves integrating sensors, actuators, and virtual interfaces to create an automated and remotely controlled home environment. System design and simulation setup. The entire home automation system was simulated on PiximLab. The Arduino acted as the central controller and it communicated with the Blink IoT platform. Sensor and actuator integration. The LDR sensor was used to monitor the ambient light and automatically control the brightness of garden lights, which is the LEDs. The LM35 temperature sensor was used to measure the temperature values for environmental monitoring. Serial tank module, which simulates the water tank to monitor and control water levels through the serial communication. IoT control via Blink application. The mobile app provided with button widgets for controlling the heater, the cooler, inlet and outlet valves. The gauge widgets displayed live temperature and water level data. And then the terminal widgets which showed system notifications and status messages. Then the automation and threshold control. If the temperature was greater than 35 degrees Celsius, the heater turns off automatically. If water tank is empty, it autofills once in the starting, and if the water tank is full, the inlet valve automatically closes. Then the display and monitoring. The CLCD module was used to print the status of the heater, the cooler and the inlet and outlet valves. And then the testing and validation, each module, that is the lighting, the temperature, the water control, was tested in simulation. The functional validation also ensured the reliable data communication between Pixim Lab and the Blink IoT app. These are the codes for the home automation Blink controlled app. This is the main home automation Blink control INO file. It includes the Blink template IDs followed by the required preprocessor directives, and then the main .h file. The .h files are included, followed by the variables which need to be initialized, and then the Blink write functions which include the which control the cooler pin, the heater pin, inlet pin, and outlet pin. Then we have the void update temperature volume reading function, which helps display the temperature and water volume as gauge on the Blink app. Then we have the handle temperature function, which turns off the heater if the temperature raises above 35 degrees Celsius. Then the handle tank, which reads the latest volume, and initial autofill is also controlled by this function. And the manual turning on and off of the serial tank. Then we have the void setup, which includes the initializing of the CLCD, initializing the LDR, the temperature system, and the updating of the temperature volume reading. The void loop, which has the repetitive statements. LDR.cpp, which has the code for controlling the LED and the LDR. As the LDR is varied, the brightness of the LEDs vary. Then the LDR.h, which assigns pins for the LDR. Then the main.h, which assigns all the virtual pins. Then the serial tank.cpp, which controls the serial tank. It has the initialized serial tank. Then the volume, which reads the volume and returns the volume value. And the enable inlet, disable inlet, and enable outlet and disable outlet functions. Then we have the serial tank, which assigns the .h, serial tank.h, which assigns pins for the serial tank. Then temperature.cpp, which has functions to read the temperature and control the cooler and heater pins. And the temperature system.h, which assigns pin for the temperature system. Simulation. Having all the connections ready, I'm going to load the hex file. Now we can see the home automation reflecting on the CLCD. And the Blink IoT app is connected now. We can see the yellow light blinking. Now we can see the serial tank being automatically filled and the volume increasing in the CLCD. And now we've switched off the inlet valve. Now the outflow is on. And I'm switching off the outlet valve. Now we'll vary the LDR. I'm reducing the LDR value. Now we can see the dimming of the LED brightness. Now I'm increasing the LDR value. The light is brightening. Now for the temperature adjustment, heater is on now. We can slowly see the temperature increasing. .6. Now I'm switching off the heater. Now I'm turning on the cooler. Now we can slowly see that the temperature will reduce. It's back to around 28 now. And if we switch off the cooler, the temperature will stabilize. So the IoT based home automation system was successfully simulated. I learned a lot through this internship. It was a very great experience. Thank you.